Hello everyone, welcome back to another AP Explain video. Today we'll be going over a daily problem for the dynamics. This will be question 10 in the MIT AP Physics 1 workbook that will be in the description down below for you guys to follow along. With that being said, let's go ahead and read the question. A plane 5 meters in length is inclined at an angle of 37 degrees as shown above. A block of weight 20 newtons is placed at the top of the plane and is allowed to slide down. The magnitude of the normal force exerted on the block by the plane is, and then we have our answer choices. So, going ahead, we can go and draw our free body diagrams as necessary. One thing I would like to do is quickly crossing out choice D, because we can automatically see that the normal force is going to add something since it's adding in the perpendicular here, perpendicular to the surface. So automatically we can go ahead and cross out choice D. Now, with that being said, we can't cross out any other choices because we don't know based off our calculations. So here we now need to go and list our known variables. So we know that the degree, which is theta, is equal to 37 degrees. We know that the block has a weight of, so weight is equal to 20 newtons. And other than that, we don't know, other than the distance we know is 5 meters, but that is something we will not need to use right now. So drawing our free body diagram, we can go ahead and take our square and draw it right here. So we have our square up here, and then we have the forces acting on it. So first off, we're going to have our weight force, but our weight force is going to just act straight downwards. But in this case, downwards is actually at a degree. So if we take it, we're going to actually take this and draw it at this angle. And this angle is going to be right here of 37 degrees. And here it's going to be 20 newtons. Now we have to go ahead and draw our our vectors in the x component and the y component. So this is going to be weight in the x, and this is going to be weight in the y. Using theta in our hypotenuse, we can go ahead and use our trig identities. So here we would do the angle is opposite, so we know we have our hypotenuse, we have the opposite side, and we have our angle. So knowing our trigonometry, that would be sine, because sine is opposite over hypotenuse. So that means sine of theta is equal to opposite over hypotenuse. And here we have our weight in the W is going to be adjacent, and knowing our trig identities, it's going to be adjacent over hypotenuse is cosine. So cosine of theta is equal to adjacent over hypotenuse. Doing this, we can go ahead and plug our knowns. So our known here is sine theta, which is sine of 37, is equal to the opposite, which is what we don't know, weight x, over 20, and over here it would be cosine of 37 is equal to weight in the W over hypotenuse. Sorry, we know our hypotenuse, it is 20. Now to get weight W, you would multiply by 20, multiply by 20. This is 20 over here also, which you do to the left, you must do to the right. This would cancel out, 20 over here, this would cancel out, and that gives us weight in the X is equal to 20 sine 37, and I'm going to write down here weight in the Y is equal to 20 cosine 37. Now what we need to do is calculate our forces acting in which one is this going to be the y direction. The reason being, we want to know the magnitude of the normal force exerted on the block by the plane. So here we have the object right here. We have the normal force. Force normal is always perpendicular to the perpendicular to the surface. And here we can see that in our object it is perpendicular, so it's going to be pointed this way. And sorry if this arrow was drawn incorrectly earlier. It should be pointed downwards this way as the force gravity, as we can see over here. So our normal force is going to be pointed upwards, but there's one thing we need to know. The object is going to be able to slide down, and since the object is going to be able to slide down, it is going to be going in the x direction, because here we're going to categorize this as our x and y components. So this is going to be our x-axis, and this is going to be our y-axis. And since this is our x and this is our y, going downwards is going to be positive and the other way is negative. And since it's going down the positive x-axis in a straight line according to this surface, that means all the motion is going to be in the x direction, meaning that the forces in the y should equal each other out. And knowing that they should equal each other out, that means that there is no acceleration. So if we set up our equation, sum of forces is equal to mass times acceleration, and this is in the y, it is going to be sum of forces is going to be force normal, and what is acting downwards is going to be this y in the w, the weight in the w. So it's going to be minus weight w is equal to the mass, which is a times 0. So this all becomes 0. We don't really need the weight, the mass anyways, if that's what you were wondering. So our force normal is equal to weight w. And as we said over here, weight w is equal to 20 cosine. So that means it's going to be force normal is equal to 20 times cosine of 37. And I could go ahead and calculate this, but we know that when we multiply cosine of an angle less than 90, it is going to decrease. So knowing that, we know it can't be A because that'd be greater than 20. We know it can't be 20C because it would be equal to, and that leaves us choice B as our answer because 20 times cosine of 37 is going to be less than 20, but it is going to be greater than 0. And to check that, we can do 20 times cosine of 37, and that gives us the answer of force normal is equal to 15.97 newtons. I hope you guys enjoyed the video. If there's anything you didn't understand or needed to be explained, please comment down below what you didn't understand. I wouldn't mind going over these videos again and going through your comments. Hope you guys enjoyed the video. Please continue prepping and remember to enjoy life.